Hello everyone, welcome to my channel Mathematics for Kids. Today and in this video we are going to talk about polygon. What is a polygon? In geometry, a polygon can be defined as a flat or plane. It is also two-dimensional closed shape. Besides that, it is bounded with straight sides, so it doesn't have curved sides. So the shape to be a polygon, it must satisfy three conditions. It must be flat, closed, and bounded with straight sides. A polygon is specified by two main characteristics. The first one is the sides of the polygon that are called the edges. So the sides of the polygon are called the edges of the polygon. The second one, the points where the two sides meet are the vertices or the corners of the polygon. So we have the sides of the polygon that are called edges, and the points where the two sides meet are the vertices or the corners of the polygon. Let's take an example. Here we have some shapes and we need to check if these shapes are polygon or not. Let's start by the first shape, shape A. Is A polygon? Yes, it is polygon. Since A satisfies the three conditions. It is flat, it is closed, and it is bounded with straight sides. Shape B. Is B a polygon? No, it's not. Even if it is flat and it is closed, but it's not bounded by straight sides. It's bounded by curved, so it's not polygon. C. Is C a polygon? Yes, it's polygon, since it is flat, closed, and bounded with straight sides. Now D. Is shape D a polygon? No, it's not a polygon. Even if it is flat, and even if it is bounded with straight sides, but it is not closed, it is open shape, so it's not polygon. Shape E. Is E a polygon? Yes, E is a polygon. Since E satisfies the three conditions, E is flat, E is closed, and E is bounded with straight sides, so E is a polygon. Is F a polygon? For sure not. F is not a polygon. Even shape F is flat and closed, but it is not bounded with straight sides. F bounded with curve. Now shape G. Is shape G a polygon? Yes, it's a polygon. Shape G is flat, closed, and bounded with straight sides. Shape H. Is shape H a polygon? For sure not. Shape H is not flat. Even it is closed and bounded with straight edges, but shape H is not two-dimensional shape. It's three-dimensional shape. It's a cube. Now the last shape I. Is I a polygon? Yes, for sure it's a polygon. It is closed, flat, and bounded with straight sides. Now, after recognizing the shapes, if they are polygons or not, let's talk about the names of the polygons. Polygons are named on the basis of the number of sides it has. So, polygons are generally denoted by n-gon, where n represents the number of sides the polygon has. For example, if a polygon has 5 sides, so it is named 5-gon. And if we take another example, if we have 10-sided polygon, so this polygon is named 10-gon, and so on. But we have a few polygons have some special names. The minimum number of sides a polygon can have is 3, because it needs a minimum of 3 sides to be closed shape, or else it will be open shape, so it will be not a polygon. Here we have some names of polygon, for sure according to the number of sides. If the number of sides of the polygon is 3, then the polygon name is triangle. If the number of sides of the polygon is 4, the polygon name is quadrilateral. We are going to talk longly about quadrilaterals in the other videos. If the number of sides is 5, then the polygon is pentagon. If the number of sides is 6, then the polygon is hexagon. If the number of sides is 7, then the polygon is heptagon. If the number of sides is 8, then the polygon is octagon. And we have also, if the number of sides is 9, then it is nonagon. If the number of sides is 10, then it is decagon. Here, even though polygons with sides greater than 10 also have special names, we generally denote them by n-gon, as we mentioned before. And because the names are so complex and it's not easy to remember, for this reason we use n-gon. Up till now, we talked about polygon, the definition of polygon, and the name of polygon. Now, in this part, we are going to talk about the types of polygon. The polygon can be classified on the basis of the number of sides and the angles it has. Let's start by the classification on the basis of sides. We have regular and irregular polygons. Let's start by the regular polygons. Regular polygons are polygons that have equal sides and angles are also equal. Let's take some examples. A square. A square is a regular polygon because the sides of the square are equal and the angles are also equal. A square is a part of the quadrilateral, and we are going to talk longly about the properties of the square and the other types of quadrilateral in the other videos, as we mentioned before. Another example, equilateral triangle. Equilateral triangle is also a regular polygon because it has equal sides and equal angles. Regular hexagon. Regular hexagon is also a regular polygon because it has equal sides and equal angles. And the classification on the basis of sides has another type, which is irregular polygon. Irregular polygon is a polygon with unequal sides and angles. Here we have some examples. The first example is the scalene triangle. The sides of the scalene triangle are different in length and the angles also have different measurements. The other example is irregular pentagon. Also here the irregular pentagon have unequal sides and unequal angles. Now the classification on the basis of sides is done. Let's start by the classification on the basis of angles. We have two types of polygons, convex and concave polygons. Let's start by the convex polygons. A convex polygon is a polygon with all interior angles less than 180 degrees. Before taking some examples about convex polygons, here we have a very important note that in a convex polygon, all diagonals are in the interior of the polygon. What does diagonals mean? Diagonal is a line segment joining any two non-consecutive vertices of a polygon. So, these diagonals are interior of the polygon. Let's take some examples. Here we have three convex polygons. Why they are convex? Because all the interior angles less than 180 degrees. The first polygon is pentagon because it has 10 sides. The second one is trapezoid, and all the angles in the trapezoid are less than 180 degrees. And the third shape is heptagon because it has 7 sides. And here the angles of the heptagon are less than 180 degrees. For this reason, the three shapes are convex polygons. The second type of polygons, according to the classification on the basis of the angles, is concave polygons. A concave polygon is a polygon with at least one interior angle greater than 180 degrees. And here we also have a very important note that in a concave polygons, not all diagonals are in the interior of the polygon. Let's take some examples. Here we have two polygons, and as you see, in the first polygon, we have one interior angle greater than 180 degrees, which is here. And in the second shape, we have two interior angles greater than 180 degrees. And these are the interior angles that have greater than 180 degrees measurement. So these two shapes or these two polygons are concave polygons. After defining the polygon and talking about the names and the types of the polygon, finally we are going to talk about the sum of angles of a polygon. First, the sum of the interior angles of the polygon with n sides is equal to the number of sides n minus 2 multiplied by 180 degrees. So the sum of the interior angles of a polygon with n sides is equal to n minus 2 multiplied by 180 degrees. Let's take an example. Here, consider the following polygon with 6 sides. What is the sum of the interior angles of this polygon? Since we know the rule, that is, the sum of the interior angles of 6-sided polygon is equal to n minus 2 multiplied by 180 degrees. And n here is the number of sides of this polygon, which is equal to 6. So it is equal to 6 minus 2 multiplied by 180 degrees, which is equal to 4 multiplied by 180 degrees. It is equal 720 degrees. So the sum of angles of the polygon with 6 sides is equal to 720 degrees. Let's take another example. In this example, we are going to find the number of sides, not the sum of the interior angles. Here we have the sum of the interior angles in a polygon is 1620 degrees. And here we have to find the number of sides that this polygon has. In order to find the number of sides, we have to find n by using the rule. The sum of the interior angles of a polygon of n sides is equal to n minus 2 multiplied by 180 degrees. And here we know the sum of the interior angles. The sum of the interior angles is equal 1620 degrees. So we substitute 1620 degrees is equal to n minus 2 multiplied by 180 degrees. This is an equation. So we divide 1620 by 180 and to find n minus 2, and 1620 by 180 is equal to 9, then n minus 2 is equal to 9. Then continue solving this equation in order to find n. N is equal to 9 plus 2, which is equal to 11. So this polygon has 11 sides. As a result, we can use this rule in order to find the sum of the interior angles of a polygon or to find the number of sides of this polygon. Now, the second point related to the sum of angles in a polygon is the sum of the exterior angles of polygons. The sum of the exterior angles of polygons is equal to 360 degrees. The sum will always be equal to 360 degrees, irrespective of the number of sides it has. For example, consider here the following polygon with 5 sides. Here, the sum of the exterior angles in this polygon is equal to 360 degrees. Since the sum of the exterior angles of the polygon is equal to 360 degrees, then each exterior angle is equal to 360 degrees divided by n. 360 degrees divided by n is 360 degrees divided by the number of the sides of this polygon, which is 5. So 360 degrees divided by 5 is equal to 72 degrees. Here, the exterior measure of each angle in this polygon is equal to 72 degrees. Let's take here an example. In this example, we have to find the measure of each exterior angle of a regular polygon of 20 sides. Here we have a polygon of 20 sides. So this polygon has n equal to 20. And we know that the sum of the exterior angles of a polygon is equal to 360 degrees. So each exterior angle is equal to 360 degrees divided by n. 360 degrees divided by n is 360 degrees divided by the 20 sides, which is equal to 18. So each exterior angle of this polygon is equal to 18 degrees. And we finish this chapter. In this chapter, we talked about the definition of polygons, the name of polygons, and the types of polygons, and finally we mentioned the sum of angles in a polygon. Now, if you like this video and if you enjoy watching it, please share it with your friends and subscribe to my channel. Thank you very much for watching. Bye bye.